Alrighty, we are continuing our study of quadratics, and we're moving closer and closer to being able to solve quadratics algebraically. Right now, we're just focusing on how to factor quadratics. So we are in section 7.3. The start thinking part says, find the two binomial factors of the following trinomials. So the first one is just x squared plus 6x minus 7, and we are using the box method that we learned in the last lesson. So what you're going to do is you're going to have your box. The top left corner is that first term of x squared. The bottom right is going to be the negative 7. And then you have to use your ACB chart to figure out what the other two terms are. Remember, an ACB chart is the A value times the C value, and that in this case it is 1 times negative 7. That gets you negative 7, and the B is 6. So you're finding two numbers that multiply to get negative 7 and add to get 6. Well, we know it's going to be a negative and a positive, and the positive is going to be bigger because when they add together, they get a positive number. So it ends up being 7 and negative 1. So you fill in those other boxes. In class, kids were accidentally just putting 7 and negative 1 and not 7x and negative 1x. And remember, the reason we're able to do this is because 7x minus 1x equals the 6x that was originally in our expression. Once you have that, you figure out what times what is going to get you your x squared, that's x times x, and then what times x gets you negative 1x, and that's negative 1, and what times x gets you 7x, and that's a 7. And now you have your two binomial factors that can be FOILed together and get your trinomial of x squared plus 6x minus 7. And those two binomials are x minus 1 and x plus 7. On the next one, this one was much more challenging. Still, we went over and filled out the top left box and the bottom right box with the 12x and the minus 10. After we had that, we did our ACB chart. This one was much trickier to find the two numbers that multiply to get negative 120 and add to get negative 7, and it is 8 and negative 15. So we put those in the boxes, and we were able to figure out what the binomial factors were. This is much more tricky because you have to ask yourself what times what gets you 12x squared. And there's many options. There is 12x and 1x, there's 4x and 3x, there's 6x and 2x. So there's many different ones. You kind of have to play around with it. And we ended up getting 4x and 3x. And then once you had that, you were able to figure out what the other parts were, which was negative 5 and 2. So you now have your two binomials of 3x plus 2 and 4x minus 5. You can just FOIL those together to check your answer, and you'll get back to the 12x squared minus 7x minus 10. Now, I'm going to be teaching you a new method of factoring. Before we get to this method, I have these problems right here in the next section where it says developing an algebraic model for factoring. I have 4 terms, and what you are supposed to do is treat each one of the groupings as its own deal and then try to factor out a monomial by undistributing, that type of factoring. And then do the same thing for the second one. But when you do it to the second one, you're trying to factor out something so that what's left over in the parentheses is the same thing you had in the first grouping. So when we look at this, an A, what you can factor out would be an x, and you would be left with an x plus 5. That tells me the other one I want to be an x plus 5, and I could either take out a 1, a negative 1, a 7, or a negative 7. And in this case, it made more sense to take out a negative 7 because we wanted to have that x plus 5. Now that you have that, you can see that both of the terms have an x plus 5. It's x times x plus 5 and negative 7 times x plus 5. And they both have an x plus 5, which means you would be able to factor out that x plus 5. That's how I got the first binomial of x plus 5, and what's left over is the x and the negative 7. That makes the other binomial. On the next problem here, you have your first grouping. You can pull out an x, leaving you with the 2x minus 3. That tells you on the next one, you want to pull something out so that you end up with a 2x minus 3 as well. And what I was able to factor out was a negative 2. Now that we have that, they both have a 2x minus 3 as a factor, so I can pull those out, getting a 2x minus 3, and then the x minus 2 is left. And therefore, you will have a binomial of 2x minus 3 and x minus 2. On the next one, you do the same exact thing. You look at the first grouping of x squared plus 4x. You could factor out an x, leaving you with an x plus 4. You know the other one needs to be an x plus 4, but since it already is, you still need to factor something out. So you factor out a 1. In this case, they both have an x plus 4, which you could take out of both of those terms. That's how you get the x plus 4 in front. And then what's left over is the x and the 1, so you say x plus 1. On the next one, you're able to pull out an x, factor out an x, and you end up having a 3x plus 2, which tells you the other one has to be a 3x plus 2. So I'm going to pull out a 4, and not only a 4, but a negative 4, so I'm left with a 3x plus 2. The two 3x plus 2's can be factored out, and then you'd be left with an x minus 4, and that's how you get your two factors of 3x plus 2 and x minus 4. This is the basis of how you guys are going to be factoring. Let's take a look at the step-by-step factoring method. So when you look at this, the first thing you need to do is you get your trinomial and you figure out what your a, b, and c are, and you make your ACB chart. When you do that, in this case, you get a times c is 24, 3 times 8, and then your b is 10. You have to find two numbers that multiply to get you 24 and add to get you 10. There's many numbers that multiply to get you 24, but only one pair that will also add to get you 10, and that is 6 and 4. So what you do here is you write the first term, which is 3x squared. You write the last term, which is an 8, but instead of having a 10x, you write that as 6x and 4x. So now you have these four terms, just like the ones we were dealing with in the section right above. The biggest thing that people mess up on is they forget to write out the first and the last term. A previous teacher who used to be at our school used to call this the pants method, because when you have the 3x squared going to where 3x squared is and the 8 going to the 8, and then you split up that middle term, it looks like a little pair of pants. So once you have that, then you're going to group the first two terms, factor out what you can, which is a 3x, leaving you with an x plus 2. The other one, you want to end up with an x plus 2, and you find out what you're going to factor out, and you could factor out a 4, so you would divide both of those by 4, and that leaves you with an x plus 2. And just like we did before, you would factor out the x plus 2, so that is one of your binomials, and 3x plus 4 would be left over, and that's your other binomial. So this is a different method that you can use instead of the box method. The good thing with this is you have to guess and check for the ACB chart, but there's no other guessing and checking. It's just factoring. Whereas in the box method, not only do you have to guess and check for the winning pair for the ACB chart, but once you have that, you have to figure out, like in the case of B, what things multiply to get you 12x squared. It might be 3 and 4, negative 3 and negative 4, 6 and 2, negative 6 and negative 2, 12 and 1, negative 12 and negative 1. So anyways, this way is the way I usually factor. So the students had to try out these problems right here, and they were able to use whatever method they wanted, but I wanted to encourage them to at least try this a few times. So on this first one, you would write the first term and the last term, and then that middle term of negative 2x, you would make negative 5x and a positive 3x by using the ACB chart. Once you have that, you would group it, factor out an x, leaving you with x minus 5, and the other one you would factor out a 3, leaving you with an x minus 5. And the two numbers on the outside make one binomial, the x and the 3, and the two numbers, or not numbers, but the two things inside the parentheses, the x minus 5, make the other one. So it'd be an x plus 3 and x minus 5. Those are your two binomials that can be FOILed together to get your trinomial. In the next one, you do the same thing. You write the first term and the last term, but the middle term you are going to break into two things, which is negative 6 and 5 by using your ACB chart. Once you have that, you group them. You factor out what you can out of the first, getting a 2x. You factor out a 5 out of the second, so that both of the inside the parentheses are an x minus 3. And then you have the two binomials of 2x plus 5 and x minus 3. And we did the same exact thing for the last one. You write the first term and the last term, but the middle term needs to be broken up into two different terms. The way we find out what those numbers are by using our ACB chart. Once you have those, you group them, factor out what you can from the first one, which is just an x, leaving you with a 3x plus 4, and then factor out what you can from the next one, which is negative 2, leaving you with a 3x plus 4. And you end up getting two binomials, x minus 2 and 3x plus 4. Now, mathematicians are always looking for efficiencies and quick ways of doing things. So we looked at these factored forms, which is x plus 5 and x minus 5, 3x plus 2, 3x minus 2, 2x plus 3, 2x minus 3, 4x plus 1, 4x minus 1, and we FOILed them. What we ended up getting was x squared minus 25, 9x squared minus 4, 4x squared minus 9, and 16x squared minus 1. And what we found with all of these cases was that the middle term went away. The coefficient, the number part of the first term, was always a perfect square, 1, 9, 4, 16. Those are all perfect squares. And the end was also going to be a perfect square. 25, 4, 9, and 1 are all perfect squares. The other part is that there's always a minus in between. We call this the difference of squares. Difference means subtracting, and we have squares here. And how that works is if you ever catch on to the fact that you have a perfect square minus a perfect square, it factors very easy without having to do the box method or the ACB chart. For example, when we look at this, the first one was a 1 and a 25. Those are both perfect squares, and there is a minus in between. So all you have to do is square root 1, getting 1x and 1x. You can see that's the beginning of the binomials, and then the square root of 25 is 5 and 5, and it's just a plus and minus. Next one, square root of 9 is 3 and 3. Square root of 4 is 2 and 2. And then you have the plus and the minus. This works because you had a perfect square minus a perfect square. So let's look at the actual practice problems 1, 2, 3, and 4. So on these, we're trying to figure out if this is one of the special cases. And while on number 1, they are both perfect squares, you do not have a minus in between. You have a plus. So this is not going to be able to do the shortcut. Number 2 is a perfect square 9, is a perfect square 16, and there's a minus in between. So yes, we could do our shortcut. Square root of 9 is 3 and 3, so you have 3x, 3x, plus and minus, and the square root of 16 is 4 and 4. So that's going to get you your two binomials. The next one, 1 is a perfect square, 81 is a perfect square, and there's a minus in between. So you can do your shortcut. Square root of 1 is 1, so you get 1x, 1x, plus minus, square root of 81 is 9 and 9. And there are your two binomials. The next one, 16 is a perfect square, minus is a minus, but the next one is not a perfect square, so you cannot do the shortcut. Now, the last thing that we had in the notes was if you have something like this, like 2x squared plus 12x minus 14, before you do your ACB chart or do the box method, you should really see if there's anything you can factor out first. And in this case, all three of those can be divided by 2. So I originally divided out the 2, and once I had that, then I had my trinomial. I did my ACB chart, wrote it as 4 terms, grouped it, factored, and once I got my factors of x minus 1 and x plus 7, I then just put a 2 also. So it has those 3 factors, the 2 binomials, and then the number 2. So always just take that second to see if there's anything you can factor out. Let's take a peek at the homework. When you're doing your ACB chart, you have to get pretty good at finding out what 2 numbers multiply to get one number and add to get another, and that is what this was about. So you get negative 10 and 4, 10 and negative 4, 12 and negative 3, and negative 9 and 4. So it's kind of a little bit of guess and check, but you also come up with a little bit of a method. On these, students were supposed to factor either using the method we learned today or the box method, whichever they are more comfortable with. You can see on A, I got a winning pair of 9 and negative 2. I wrote those as my middle terms, grouped them, factored, and got my 2 factors. On B, I got my winning pair of 7 and negative 1. I wrote the first term and the last term, and the middle term turned into those 2. I grouped them, was able to factor out an x and a negative 1, and that's how I got my x minus 1, x plus 7. On C, your winning pair is a 3 and a 3, so you write the first term and the last term, but the middle term becomes a 3x and a 3x, group them, and then you factor out of the first, factor out of the second, and you end up getting x plus 3 and another x plus 3. So you could even write that as x plus 3 squared if you wanted. The next one, you get you write the first term and the last term, but the middle term you write as 2 things by using the ACB chart. You get negative 6 and 5, group them, factor out which came from the first, factor out which came from the second, and then you make your 2 binomials. You can see we did the same exact thing on E and F. So the hardest part here is just figuring out what your winning pair is, so you know what you're going to change your middle term into, what 2 terms. But the first stays as the first. The last term stays as the last, and on part E, it's 3x squared and negative 20 stay like that, and the middle term becomes 2 terms. And then on our last one, we have another problem here where the winning pair is negative 6 and a negative 6. You write that in, and when you do your factoring, you get the same exact thing, 2x minus 3, 2x minus 3. So that can be written as 2x minus 3 squared. On this next one, it says Hannah's trying to factor the trinomial of x squared plus 5x plus 7, and she ends up trying to find 2 numbers that multiply to be 7 and add to be 5. She finds there are none. What does this tell her about the trinomial? Well, in this case, it cannot be factored into 2 binomials. You can factor out a 1 out of all of those, but we aren't going to be able to factor this into 2 binomials. On this one right here, we're trying to figure out if any of these go along with our shortcut of perfect square minus perfect square. The first one, both of them are perfect squares, but it's not a minus, so we can't do it. The next one is perfect square, and a minus, so yes, we can. So we square root 25, getting 5x, plus and minus, and the square root of 81 is 9 and 9. And the next one is a perfect square, a minus, but it's not a perfect square at the end, so that doesn't work. And then lastly, on the review problem, The following three equations represent the same function but in different forms. Determine which function is helpful in finding each desired characteristic, and then identify the desired information. So you have it in factored form, standard form, and vertex form. So the one that helps you get the y-intercept is going to be easiest, will be form B, standard form, and the y-intercept would be 0, -24. Which one gets your zeros? That is form A. Remember, the zeros aren't the 4 and the -6. You have to set each one of those things equal to 0. So x plus 4 equals 0, so you get a -4. X minus 6 equals 0. When you solve, you get 6. And then lastly, which one gets you the vertex? That would be form C, which is vertex form. And you end up getting the vertex of 1, -25. Remember, it's the opposite of what you would assume inside the parentheses, and that is exactly what you would assume outside the parentheses. All right, hopefully this made sense. Just another way to learn how to factor. And factoring is definitely one of those things that follows you from this class to the next class to pre-calc to calculus to every class afterwards. It's like when you first learned how to solve an equation, we just kept doing it over and over and over in every class after that. Thanks for watching.